Hi, I am the AI agent guy, and today we are exploring the most capable AI coding agent yet. Building on the last video about self-testing AI agents, we are taking it a step further. If you're grappling with slow development cycles and struggling to stay competitive in this fast-paced world, you are in the right place. As an AI consultant, I've seen firsthand how AI agents improve business processes. But here's the thing, many companies still view AI agents as a future tech, not realizing they are missing out on massive productivity gains right now. This mistake is costing businesses millions in lost opportunities. Today, we'll change that. So let's dive into how the right AI coding agent can revolutionize your development process and give you a competitive edge. So stay tuned until the end to see how this AI agent beats ChatGPT in coding. But before we dive into the power of AI agents, let's address a critical question. Why aren't conversational AI chatbots like ChatGPT sufficient for coding tasks? Understanding this will highlight why specialized AI agents are game changers for your development process. First, the question-answer bottleneck. Traditional chatbots operate on a simple question and answer based model. While this works for general queries, it falls short in the complex iterative world of software development. Your developers waste valuable time switching between the chatbot and their coding environment, disrupting their workflow and creativity. Second, the lack of real-time testing. When a chatbot suggests a code solution, there are no guarantee it will work in your specific environment. Your team must manually copy, paste, and test each suggestion. This trial and error process can be time-consuming and frustrating. Third, outdated knowledge base. The tech world moves at light speed. Chatbots like ChatGPT, despite their broad knowledge, often lag behind the cutting edge. For instance, if you are working on the latest libraries, like LangChain or LangGraph, a general-purpose AI might struggle to provide accurate and up-to-date code solutions. This can lead to increased errors, longer development times, and potentially security vulnerability. And fourth, the hidden cost of hallucinations. AI hallucinates. Where the AI confidently provides incorrect information can be particularly dangerous in coding. They can introduce subtle bugs that are hard to detect, potentially leading to significant issues down the line. The cost of these errors in terms of debugging time, customer satisfaction, and potential security breaches can be substantial. And this is where AI coding agents shine. Unlike simple chatbots, these specialized tools are designed to integrate seamlessly with your development ecosystem. Here's how they address these limitations. First, real-time testing and validation. Before suggesting a solution, AI agents can test code in a sandbox environment, ensuring that you'll receive only working, validated code snippets. This dramatically reduces the time to spend on trial and error. Second, up-to-date knowledge. Specialized AI coding agents can be continuously updated with the latest libraries, frameworks, and best practices, ensuring your team always has access to cutting-edge solutions. And third, reduce error rate. By providing pre-tested contextual appropriate code, AI agents significantly reduce the risk of introducing vulnerabilities into your code base. By implementing AI coding agents, you are not just adopting a new tool, you are fundamentally transforming your development process. You are empowering your team to work faster, smarter, and with greater confidence, ultimately driving innovation and maintaining competitive edge in today's fast-paced digital landscape. Now that we understand the power of AI coding agents, let's take a quick look under the hood. This diagram illustrates the structure of a typical AI agent, showing how it integrates with your development ecosystem to deliver those game-changing benefits we just discussed. In my last video, I explained the structure of the AI agent workflow. But in this new version, I made an addition to the basic coding agent that drastically improves its capabilities in generating code. Let's do a quick walkthrough. First, like with ChatGPT, we ask some code generation or problem statement. Then the AI or LLM generates code based on our request. In the next step, it passes the generated code in a structured format to the code check agent. That starts testing the generated code to see if it works or has some bugs in it. If the generated code is error-free, then it gives us the final output. But if it does not pass the test, then it will send the generated code plus the error message back to the first agent to revisit its bad first output to improve it, and then loops through the same process. But as mentioned earlier, what if it doesn't have the knowledge in its training data? Well, then it won't be able to give us a satisfying answer. And this is where the web search agent enters the game. In case the code generation agent is not capable of solving your coding question, It will send the error message that occurred to the web search agent that will then search on the web like a human developer would do in such a case. Then read and find the solution online, but with the difference that it's light speed compared to a human. And then the loop would continue until it generates a working and tested solution for you. All this in an instant. Now, let's dig into the actual code. I'm not running through the details of every function in the script because I don't think this is useful, first of all. And second, we'll be here all day walking through every detail. You are going to have the GitHub repo available to you in the description, so you can explore that for yourself in your own time. What I'm going to talk about are the most important parts in the addition to the code from last time. Here we start by importing necessary libraries and setting up our environment. I use Streamlit for the web interface and LangGraph as the framework for the AI agent. I choose LangGraph because it's a low-level framework that provides fine-grained control over both the flow and the state of an AI agent application. Compared to other LLM frameworks, it offers core benefits like cycles, controllability, and persistence, which makes it the most reliable agent framework in my opinion. At least as of now. Remember, the technology is still in its infancy, and compared to the other frameworks, it's the most customizable, which makes it a great choice for real-world applications. On top of that, I use beautiful Zoop for scraping the web. Next, we set up the Streamlit app. This setup allows users to input their coding question while providing dedicated areas to display the AI thought process and the generated code. Next, the state management. We define a graph state class to manage the state of our application. This is basically the short-term memory of our agent. We define what information we want to pass on to the next agent in our system. This includes the user message, the generated code, and the error messages, as well as the iteration count. Next, let's break down the core functions of our application. The generate function. This function is responsible for generating the code based on our current state. It uses the LLM to create code solutions and update the state with the new generated and conversation history. And here the code check function. This crucial function tests the generated code. It attempts to execute the imports and the main code block. If any errors occur, it formats an error message and updates the state, potentially triggering a web search for more information. Next, the fetch full content function. This helper function is used to scrape content from web pages. It's particularly useful when the AI needs to gather more information from search results. Then the web search function. When the AI needs more information, this function performs the web search using the Tavli search tool. It updates the state with the search results, which can be used in subsequent code generation attempts. And next, the decide to finish function. This function determines whether the AI should continue generating code, perform a web search, or finish the process based on the current state, number of iterations, and web search attempts. And down here, the run code generation function. This function initiates the code generation process and manages the flow of operations and returning a list of events that occur during the process. Now, finally, let me run the application so you can get a better understanding of why this AI agent is such a game changer. Type streamlit run app.py to start executing the application. Obviously, the design could be improved and further customized. I just wanted to create a quick demonstration for non-technical viewers. As you can see on the left-hand side, you can type your question or request, then generate code. Here you can watch it live. It already tested the generated code in an instant. And there you have it in the application. The generated code was successfully tested and ready to use in seconds. But we're not stopping there. Look at this visualization of the AI's thought process. Notice how it encounters an error, then searches the web for a solution, and then implemented it on a fly. This level of problem solving is amazing. Now compare this to ChatGPT's attempt. See the difference? Where our AI agent delivered a working solution, ChatGPT faltered with hallucination and unusable response. You can test it for yourself. So, if you found this video valuable, make sure to like, comment and subscribe for more insights.